Okay, so now we're going to do a new proof that comes from number theory, with a Y, and combinatorics. And on the Cut the Knot website, this is going to be similar to proof 3 and 3 prime, what they did. But I wanted to modify them a little bit because you're just starting to study number theory, so I thought I'd show you something neat from number theory. And you may remember this because we covered this a long time ago. If we're going to look at a number like 6, and try to figure out the number of different divisors that 6 has. The first thing we do is we factor it into primes.
Yeah.
6 equals 2 times 3.
Yeah.
Right? And every factor of 6 needs to either have, you know, some multiple of 2 or some multiple of 3 in it.
Yeah.
Okay? Do you remember how many multiples of 2 I can choose for my factor?
You can choose 2. 2 to the 0 and 2 to the 1.
Right, so this is 2 to the 1 and 3 to the 1. So I either am going to pick no 2's or 1 2. That's all I can pick. So I have 2 choices there. And for my factors of 3, what am I going to pick?
You have no 3's or 1 3.
No 3's or 1 3. So I have 4 factors of 6. And what are the factors of 6?
They're 1, 6, 2, and 3.
1 and 6, 2 and 3. So sure enough, I get 4. And I can do it from the prime factors. Now let's do a more complicated one. Let's do 24, say.
Well, it's...
When I factor 24 into primes, what do I get?
You get 3 squared times... you get 2 cubed times 3.
2 cubed times 3. Now, how many choices do I have for my 2's that I'm going to pick in the factor?
You have 4.
4 choices. I can pick 0 2's, 1 2, 2 2's, or 3 2's. And how many choices do I have for my 3's?
2.
2. What are they?
0 3's and 1 3.
0 3's and 1 3. So I have 4 choices for the 2, 2 choices for the 3, so I should have 8 factors here.
Yeah.
Right? And when we study this, and I think this is in the next chapter, so in the next couple of weeks we'll be looking at this with you, we find something very interesting about perfect squares. Let's look at the number 9, which is 3 squared. How many different factors does this have?
It's going to have 3.
It's going to have 3 factors because I can pick 3 to the 0, 3 to the 1, sorry, that threw this little faint, and 3 squared. I have 3 choices there. And we learned something special about perfect squares and the number of factors. Do you remember what it is, or do you know?
Yeah.
What is it?
Well, only perfect squares have odd numbers of divisors.
Perfect squares have an odd number of divisors, and only perfect squares have an odd number of divisors.
Yeah.
So that's an interesting fact. So now we go to the square root of 2, and we assume it's rational again, a over b. And again, just like last time, that means 2b squared equals a squared. Right?
Yep.
Okay, how did I get from here to here?
Well, you squared everything.
I square everything,
Then multiply by b squared.
then multiply by b squared. Now, this side is an integer
Yeah.
in lowest terms, and it's a perfect square. Right?
Yep.
So how many factors is it going to have?
It's an odd number.
This is going to have an odd number of factors. Okay, this side's interesting. It's 2 times b squared. So b squared is going to have an odd number of factors, right?
Yeah.
Okay, and for every single factor of b squared, I can pair it with a 2 to the 0, an odd number, or I can pair it with a 2 to the 1, all of those factors with a 2 to the 1, right?
Yeah.
So what does that mean about the number of factors of 2 times b squared?
Well, you multiply all of it by 2.
Yeah?
So it's even.
I have an even number of factors on this side. So I have an integer 2b squared, and I have an integer a squared. This side has an odd number of factors, this side has an even number of factors. Could they ever be equal to each other?
Well, yeah. No, because odds can't equal evens.
The factors are different. They have to be different because there's an odd number of factors on this side and an even number of factors on this side. So these two numbers can't be equal to each other.
Wow.
Isn't that amazing?
Yeah.
And this comes from basic number theory. And the combinatorics part of this was realizing how we could choose, like if we had a 3 squared, we could choose 0, 1, or 2. We had 3 choices of how many powers to choose. That's the combinatorics. Remember we studied that a little bit this summer?
Yeah.
Yeah. So that is pretty neat. Basic number theory, odd number factors, even number factors. Can they be equal?
No.
Nope. All right. Pretty neat?
Yeah.
All right. On to the next one.